chapter 8, sequences and series. So we have gone through all the different concepts of sequences and series. Okay, so we saw what is a sequence, and we also saw how there is a pattern that exists between between two consecutive terms in a sequence, and that is why we call it a sequence. Okay, and we saw different types of sequence. We saw Fibonacci sequence. Okay, then we also saw arithmetic sequence and geometric sequence. And we also saw then sequences can also be termed as progression. Okay, so you have arithmetic progression, you have geometric progression, you also have other different another kind of progression, but we have not gone into it. So that's a harmonic progression. And we also saw how we can find these series. So series is nothing but the sum of all the terms. So either up to n, or if it's an infinite series, so infinite sequence of progression. Okay, we can find the sum of all the terms that are there in that sequence or progression. So that is called a series. Then we also saw what is geometric mean and arithmetic mean, and we also saw what is the relationship between the arithmetic mean and the geometric mean. So let's start off by quickly just revising all the different formulae that we have. Okay, so we will start with, say, your arithmetic progression or arithmetic series. Okay, so formulae revision. Okay, so first we will see for the sequence. Okay, so for your arithmetic progression or sequence, okay, so you will have the first term. Okay, so I will just write the general sequence. Okay, so any sequence slash progression can be given to you as A1, A2, A3, okay, all the way up to AN, or it can also go up to infinity. Okay, so this is your finite sequence when it is up to nth term, or it is an infinite sequence. Okay, when it goes all the way up to infinity. So for AP, your first term, suppose, is called A. Okay, and there is a common difference between the two terms. So that is A2 minus A1 will also be equal to A3 minus A2. Okay, and so on. So these two are the terms that we are required to know. And if we know our A1 or the first term and the common difference, then we can easily find your nth term. Okay, nth term for AP. Okay, nth term AN is going to be equal to as A plus n minus 1 B. Okay, so this is how we find our any nth term for your arithmetic progression arithmetic series. Okay, and then we will see what is the series. Okay, so this is your nth term. So series for your arithmetic progression can be given as Sn is equals to n by 2, 2a plus n minus 1 c. Okay, you can also write this in terms that n by 2, if you just know your, if you don't even, you're not given much information, also you can directly write this is as your sum of your n by 2, sum of your first term plus your last term for an arithmetic progression. Okay, so these are some very easy formulae that we have to remember when we are solving for your arithmetic progression. Okay, now we will go into our geometric progression. So GP. Okay, so for GP, your again A1 is suppose A. Okay, your first term is A, and instead of common difference, what we have here is called a common ratio. Okay, maybe I'll just write it here. Common difference. Okay, and this is your common ratio. So in your common ratio, it will be actually A2 by A1, it's A3 by A2, okay, and so on. So it is actually A n plus 1 upon an, or you can actually write this as, have to write it in A n A upon A n minus 1. Okay, and similarly, even B is actually you get as A n minus A n minus 1. Okay, so this is how you can, so if you have A1 and R, you can find your nth term. Okay, so in your nth term, for a geometric progression is given by your first term multiplied by your common ratio raised to n minus 1. Okay, and so therefore your GP can be easily, written as your A, your first term, then your second term is first term multiplied by your common common ratio. Then your third term will be again uh, first term multiplied by squared of common ratio, or in other terms, your second term multiplied by R again will give you the third term, and so on up to A R raised to n minus 1. Okay, now for your series with respect to GP, you have two, three cases. Okay, so first let's take our finite cases. Okay, so in finite cases, your Sn is equals to A Rn minus 1 upon R minus 1. This is when your R is greater than 1. Okay, and then you have, or you have Sn is equals to A 1 minus Rn upon 1 minus R, and this is for when R is less than 1. Okay, so mostly your fractions, or if it's like a decimal kind of, uh, R, then you can use this formula. And the next one you have when you have an infinite GP, okay, you can find the series as A upon 1 minus R. Okay, so this is how you can, find. So over here also, this will be only valid when your R is less than 1. Okay, so it is easy to remember most of these formulae. It's not very, very, difficult per se. And so if you keep these formulae in your mind, it will be easy. Okay, so I now we will go on to solving, few formulae. Few examples where we will see how different kind of formulae come into play, and we will see what kind of results we get. Okay, so this actually will not be Sn. It's better to denote it as S infinity, so you know that it's an infinite series that we are dealing with. Okay, so let's take our first uh, first question. So find the sum up to 10 terms of the sequence 0.7, 0.77, 0.777. Okay, so this sequence, okay, there is no immediate relation that you can make out from here. Okay, so it is a bit difficult to just put it in just a form of, say, geometric progression, or arithmetic progression. So we will try to simplify it. So how do we simplify this? Is let S be the sum of the terms. Okay. So therefore, your S can be written as 0.7 to 0.77 plus 0.7.7, and we have been given that it is up to n terms. Okay, so up to plus up to n terms. Okay, this then you can take 7 out from here. You have 0.1 plus 0.11 plus 0.11 plus 0.1. Okay. Then suppose you multiply and divide the entire right hand side by 9. Okay, so 7/9, and you multiply the numerator and you divide you put 9 also in the denominator. So you get 0.9 plus 0.99 plus 0.999 plus all the way up to your n term. So now these 0.9, 0.99, you can write them as, okay, 1 minus 0.1 plus 1 minus 0.01 plus 1 minus 0.001. Okay, similar way all the way up to your plus 10 term. Okay, so now this totally, if you get all the 1 to uh, all the ones to one side, what you get now is 7/9. Okay, so you have 1 plus 1 plus 1 plus all the way up to n into 1, okay, minus 0.1 plus 0.01 plus 0.001 plus all the way up to your n term. Okay, now you can write this as, okay, so your this actually 1 plus all the way up to your n terms. Okay, actually this shouldn't be n multiplied by 1. This is your plus n terms. Okay, you write 1 n times, so that actually becomes your n itself, and then you can turn this into write these decimal in forms of these fractions. So what you get then is 1/10 plus 1/10 squared plus 1/10 cube plus all the way up to n term. Okay. Now you can see one thing is that this eventually forms a GP with your where your A, okay, your A is your 1/10. Okay, this is a geometric progression and this can become a geometric series also. Okay, the corresponding series for that geometric progression. So over here, your A becomes uh, 1/10, and you can see that your R is also actually 1/10 over here. Okay, because if you multiply 1/10 into 1/10, you will get 1/10 squared. Then 1/10 squared multiplied by 1/10, you will have 1/10 cube. So this way, so your R also now becomes 1/10. Okay, so therefore, in simplified way, you can then find n minus. Now you write the series formula for the geometric progression. What is the series formula for geometric progression? Cp is A. So over here you have 1 upon 10. So over here we have R less than 1. Okay. So hence this will be 1 minus Rn upon 1 minus R. Okay. So you can just substitute for the terms for this geometric progression for this, entire sum. So as 1 upon 10, 1 upon, sorry, 1 minus 1 upon 10 raised to n, and then again this will be 1 minus 1 upon 10. Okay, so this is now simplified to this form. Now quickly, if you can, this side, this becomes 7 by 9. This is n. Okay, then over here what we get is this will become your, if you this becomes your 9 upon 10. Okay, so 9 upon 10. If you take 10 to the denominator, your 1 upon the 10 gets cancelled. So what you're left with is 1 upon 9. Okay, multiplied by 1 minus 1 upon 10 raised to n. Okay, then this can be written in the form as 7 by 9. Okay, 9n minus 1 minus, sorry, this will be now plus 10 raised to minus n. Okay, so you just take this to your numerator and the whole thing divided by 9 again. Okay. So this then becomes 7 by 81. Okay, if you take 9 outside and you are left with 7n, sorry, 9n minus 1 is 10 raised to minus 10. Okay, so obviously now this is the, the generalized kind of, generalized, sum for the sequence that has been asked. Okay. Now you can obviously, if you are given a certain, value of n. Okay. For example, if we, using, I write this. Okay. So let this be your A part, and sorry, A part is find the sum. Okay. And let B is that find the sum up to say 5 terms. Okay, so we have our S is equals to, what did we get? 7 by 81. Okay, 9n minus 1 plus 10 raised to minus n. Okay, so this is a B part. So for your B part, we have said that n is equals to 5. Okay, so your S is going to be 7 by 81, 9 into 5 minus 1 plus 10 raised to minus 5. Okay, so if you quickly, kind of find it out. So let's see 7 by 81 outside, and you have 9 into 5 is 45. So yeah, 45 minus 1 plus 0.0000. So 5, 1, 2, 5. So yeah, okay. So this becomes your answer. Sorry, for 10 raised to minus 5. So now you can just add that to your 44. So you have 7 by 81 multiplied by 44.00001. Okay, so then this actually becomes 3.80247. Okay, so this will be your answer. So first we got it in the general term where we can put our any n value that is asked by that we are asked to find for. Okay, and then you just substitute the value for n and you can find the answer. Okay, so let's take another question. Express the recurring decimal 0.2 7 infinite GP and find its rational value. Okay, so when you have this bar over 3, that means your 3 is recurring. Okay, so your 3 is recurring after your decimal point. So therefore, that means that 0.3 bar is actually 0.333 and so on. Okay, so we have to write this in terms of a geometric progression. Now, if you see that if you go on adding, say 0. Go on adding your 0.3 with the next one being one decimal point more. Okay, whether 3 shifted by one more decimal point. So this can actually be written as your 0.3 bar can be written as say 0.3 plus 0.03, and then again the next one will move one more decimal point away. Okay, and so on. Okay, and you can just write a few more so you can get the idea of it. 000. You can see that your decimal the numbers after the decimal point, okay, it's increasing. Okay, and this we are considering it as an infinite GP. Okay, so infinite progression. Now this you can write 0.3 can be written as 3 by 10. Okay, and this can be written as 3 by 100. So let's just write 3 upon 10 squared. And plus you have again 3 divided by 10 cube plus 3 divided by 10 raised to 4 and so on. Okay, so now this this is okay. So now you can see that this is actually in terms of a series of a geometric progression itself. And from here we can see that your A actually becomes 3 by 10. Okay, and your common ratio R is actually your 3 is constant, so your R actually then becomes 1 by 10. Okay, because 3 by 10 multiplied by 1 by 10 again will give you 3 by 10 squared. Okay, so this is the case. And we can see that R is less than 1. Okay, so now we have been asked that we have to find the rational value for this. So rational value for this is actually this 0.3333. Okay, and we can see that 0.3 is actually the sum of the geometric progression. Okay, of 3 by 10, 3 by 10 square, 3 by 10 cube. So if you find the sum, the geometric series of this, okay, or the series of this geometric progression, we can find the rational value for 0.3 bar. So that's how will you will get it as. Okay, So we have 0.3 bar is equals to your, the GP. I'll just repeat it over here. So you can, refer to it. So it's 3 by 10 plus 3 by 10 square plus 3 by 10 cube and so on. Okay, and we can see that it is an infinite GP. Okay, infinite GP. Therefore, your S infinity, okay, so S infinite is going to be equal to your, and we know that the sum is actually going to give you this value, but we want to find it in the rational form. So now we can just write the infinite formula. So what is the formula? A upon 1 minus R. Okay, so we know our A is 3 by 10 upon, now we have 1 minus, why 1 minus R? Because our R is less than 1. So our R was 1 upon 10. Okay, so this can be written as 3 by 10, and then we will have this divided by 9 by 10. Okay, so this if you get, so you have 3 by 9, and this is 1 by 3. Okay, so therefore we can say that the in the rational form, your 0.3 bar actually is equal to 1 by 3, and this is our answer. Okay, so anytime you are given, such a recurring decimal kind of, as we saw in the first question as well as in this question, any kind of recurring, decimal term can be expressed in form of geometry progression also. Okay, when you simplify it and you get it in terms of a, geometric series, and then that will eventually give you the geometric progression term. Okay, just wait, excuse me a moment. Now over here also we actually found the uh, sum of the infinite series, or sorry, sum of the infinite terms in the progression. Suppose we were asked to find the sum up to say 4 terms. Okay, so 4 terms you can easily find your Sn. So S4 would be your A 3 by 10. Now since it is R is less than 1, so we have 1 minus 1 upon 10 raised to 4. Okay, and divided by 1 minus 1 upon 10. So this you can write as, so your 3 by 10 and this is 9 by 10, this gets cancelled and you will get 1 by 3 over here. And this will be 1 upon, so 10 raised to minus 4. So that is going to give you, so you have 1 minus is 1 by 3 multiplied by 0.9999, and this eventually gives you 0.3333. Okay, so this is the sum. Now, if you actually see that if you had, just multiplied in the form of the geometric progression itself, 0.3 plus 0.03 plus 0.003 plus 0.0003. If you sum this up, this also eventually gives you 0.3333. Okay, so it is easier to find the sum, quickly if you have the formula, if you use the formula and not do the the manual time intensive calculation. So let's take another sum question. The sum of the first three terms of GP 21 by 2, and the product is 27. Find the common ratio. Okay, so for a GP, okay, so the GP that is given, so the first three terms, so you will have AR, AR squared, AR cubed, and so on. Okay, so let the three terms be AR, AR squared. Okay, but over here you can see, we have to find the product also. So you can also write this like if you divide the entire, geometry progression by R. Okay, so you can get this as, okay, A by R, AR by R will give you A, and your AR squared by R is going to give you AR. Okay, now we know what is given to us is that the product of these three terms is actually 27. Okay, so we can have A by R multiplied by A multiplied by AR, okay, is 27. So you can see that we have actually, written it in this form. So your R and R can get cancelled in the form of a product. And what you're left with is A cube is equals to 27. And therefore your A is equals to 3. So we got our first term. Okay. Now we can write that A by R plus A plus AR. Okay, so the sum is also given to us is 21 by 2. Okay, you can quickly substitute for your A everywhere. So that is 3 by R plus 3 plus 3R is equals to 21 by 2. Okay, so then what you get is taking your 3 out, and you have 1 by R, okay, plus 1 plus R is equals to 21 by 2. Okay, so if you take this to the other side, okay, so you will have 1 by R plus 1 plus R is actually going to give you 21 by 3 into 2, so it is 7 by 2. Okay, now get this in the, you will get, kind of the quadratic form of this 7 by 2. Okay, and your R will go over here. So you have this. Now, if you get this on the other side, you have R squared plus R plus 1 minus 7 by 2 R is equals to 0. So this you will get as R squared minus 5 by 2 R plus 1 is equals to 0. Okay, so if you want to get your minus 5 by 2, then it has to be, so R, you can have your R minus 1 by 2 and R minus 2. Okay, why? Because if you add this minus half minus 2, you will get it as minus 5 by 2. And the product of this is also going to be 1. Okay, so therefore this is what you have. So your R can either be 2 or R can be half. Okay, so with both of these, common ratio, you can get your GP which fulfills your given condition. Okay, let's take another, another question. So the question is, find the GP of the sum of the first two terms is minus 4 and the fifth term is 4 times the third term. Okay, so we have been given two conditions where the sum of the first two terms of the GP is minus 4 and the fifth term is 4 times the third term. Okay, so let's just write it as, okay, so our first term will be A, and the common ratio that we usually have is common ratio is equals to is going to be R. Okay, and therefore the sum of the first two terms, okay, so A1 is R, so your A2 will be AR. So therefore A plus AR is equals to minus 4. So let this be your 1. Okay, so this is your given. And your next condition is that your fifth term, okay, so A5 is equals to 4 times A3. Now A5 you can write it as, in the terms of your A and R, R raised to n minus 1. So AR4 is going to be 4 times AR squared. Okay, so you can simplify this further and then you will get your value for R. Okay, so A gets cancelled and you will have R squared is equals to 4. So R is equals to plus or minus 2. Okay, now what we can do is we can substitute the value for R in 1. Okay, so substitute values of R in 1. Okay, so for when your R is equals to 2, okay, suppose we take the positive one, when R is equals to 2, okay, so you have A plus AR, okay, so you will have A plus 2A, okay, because our R is 2 and this is minus 4, so you can write this as A 1 plus 2 is equals to minus 3, so this is 3A, but this is minus 4, so minus 4. So 3A is equals to minus 4 and A is equals to minus 4 by 3. Okay, so let us consider only this. Even if you take your R is equals to if minus 2, then this will become A plus minus 2A equals to minus 4. So then this will actually become your minus A equals to minus 4 and A will be 4. Okay, so you can get two different, geometric progression depending on what you take your R as. So, if your for when your R is when R is equals to 2 and when R is equals to minus 2. Okay, so then your A, the first term A1 is minus 4 by 3. Your A2 will be A into R. Okay, so our R is 2, so this is going to be minus 4 by 3 multiplied by 2, so this is minus 8 by 3, and similarly your third will be minus 8 by 3 multiplied by 2, so this is minus 16 by 3. Okay, so this is your the terms of the GP when your R is equals to 2, when your R is equals to -2. Okay, so your A is going to be 4, A1. Okay, your A2 is going to be the first term multiplied by R, so that is 8. And if your A3 then becomes 16. Okay, so you can just write GP is -4 by 3, -8 by 3, and -16 by 3. And over here, your GP is 4, 8, 16. Okay, you can see that, just changing the sign of the common ratio also, you can end up with a very different, GP. Now, let's take another example. Uh, Add slide. Okay, so the next question that we have is find x and find x and y whose arithmetic mean is 25 and geometric mean is 7. Okay, so we have two positive numbers. So x and y. Okay, so arithmetic mean will be given as x plus y, and since you have n is equals to 2. Okay, and your GM is going to be root of x, y, the product. Okay, so therefore your x plus y by 2 is equals to 25, and this will be x plus y is equals to 50, and your GM is given to you as 7 is equals to root of xy. So this will be your 40, if you square both these sides, you have 49 is equals to xy. Okay, now your product is say 49. Okay, now if your product is 49, there's only one way how your equation, using your equation 2, you can satisfy your equation 1. Okay, so this means that your x is equals to 1 and y is equals to 49, and only then can you get 1 plus 49 is equals to 50. Okay, so this is a straightforward question. You just have to compare it, how you find the roots of a quadratic equation. Okay, let's take another example. Determine the R, the common ratio of GP, where the first term is 5 and fourth term is 40. Okay, so we have to find R. So we have been given R, given A is equals to 5. Okay, and A4 is equals to 40. So A4 can also be written as AR cube is equals to 40. Okay, so therefore your 5R cube is equals to 40. So R cube is equals to 40 by 5, and R cube is going to give you 8, and we know that cube of 2 is going to give you 8. So therefore your R is equals to 2. Okay. So suppose you are asked to find the second part of this find GP up to say 8 terms. Okay, so we have A1 as 5, and we have been given A4 also as 40. Okay, so let's you know kind of find the GP up to 8 terms. So you will have A2, this is to 5 into 2, so that is 10. A3 is equals to 10 multiplied by 2, 20. A4 is given, so A5 is going to be 40 into 2, that is 80. A6 is 80 into 2 is equals to 160. A7 160 into 2 is going to be 0, 12, and 320. And your A8 is going to be 320 into 2 is going to be 640. Okay, so your GP is starting from 5. GP is 5, 10, 20, 50. Sorry, there will be 40 over here. So 40, 80, 160, 320, 640. Okay, so let's take the question. Suppose the question is, if A is the arithmetic mean, okay, and G1 and, G1, G2 are the two geometric means between any two numbers, then show that 2A is equals to G1 squared, G1 squared by G2 plus G2 squared by G1. Okay, so this is what we have. Now we will, assume that let A and B be the two numbers. So therefore, your arithmetic mean, okay, we have already given it as A. Okay, so your A is going to be A plus B by 2. So this gives you A plus B is equals to 2A. Okay. Now we are saying that G1, G2 are two geometric means. Now when we have geometric means, the numbers are supposed to lie anywhere between the two numbers that we are considering for the mean. Okay, so therefore A, G1, G2, B are the is the geometric progression. Okay, so this means that your G1 by A is going to be equal to G2 by G1 is going to be equal to by B by G2 is equals to R. Okay, so your common ratio can be found in this manner. So therefore, if you consider your, G1 by A is equals to G2 by G1, okay, so this will eventually give you A is equals to G1 squared by G2. And similarly for your, B, you have G2 by G1 is equals to B by G2. So this will give you B is equals to G2 squared by G1. Okay. So now over here you can, input your values for, A and B in, this your first equation. Say this was your first equation. So substituting values for A and B in 1, you get A plus B is equals to G1 squared by G2 plus G2 squared by G1 is equals to 2A. Okay, and this is what we were asked to show. That 2A is equals to G1 squared by G2 plus G2 squared by G1. So this is your answer, and then you can just, say that it is hence true. Okay, let's take one more sum, the last sum for today. Okay, question. Find the sum to infinity of the series 1 plus 2 by 3 plus 6 by 3 squared plus 10 by 3 squared plus 14 by 3. So, okay, this is cube and all the way. Okay, so we have to find the sum of this. So we can say let S be the sum. So 1 plus 2 by 3 plus 6 by 3 squared plus 10 by 3 cube plus 14 by 3 raised to 4. Okay. So over here you can again, kind of, notice that there is not, it's not clear what is the common ratio, what is the relation between the consecutive terms and the sequence. So we can do is now let S by 3. Okay, so divide this entire, say equation 1 by 3. Okay. So not multiply, divide 1 by 3, you get 1 by 3 plus 2 by 3 squared plus 6 by 3 cubed plus so on. Okay, let this be this. Now we will subtract subtract 2 from 1. Okay, so 2 from 1, so you have S minus S by 3, so that is going to be 1 plus 2 by 3 plus 6 by 3 squared plus 10 by 3 cubed and all the way up to, infinity and minus 1 by 3 plus 2 by 3 square plus 6 by 3 cube plus all the way. Okay, so this then eventually turns out to be, just add another slide. Okay, so therefore, what you now have is 2s by 3, okay, is equals to, now you have 1 plus, now what we will do is that over here you have 1 by 3 and you have 2 by 3. So you will, the 1 will stay, separate. Then you have 2 by 3 minus 1 by 3 over here because these two have the, the common denominator over here. So then what you get is 1, 1 by 3 plus the next one will be 4 by 3 square plus you will then have 4 by 3 cube. Okay, because what now you have 6. Okay, 6 minus 6 by 3 squared minus 2 by 3 squared is going to give you 4. And even 10 by 3 cube and over here minus 6 by 3 cube is going to give you 4 by 3 cube. Okay, and this will go on. Now you can, try to, get 2 by 3 on the other side. Okay, and you can, multiply 3 by 2 for to the entire your right hand side. What then you get is 3 by 2. Okay, plus you multiply 3 by 2 here. Okay, you get 1 by 2. And then you multiply 3 by 2 here. So you will get 2 by 3. And then you multiply 2 by 3 here. So you get this as 2 by 3 square and plus so on. Okay, and now this you can, you know, add together. So you have 4 by 2, so that is going to give you 2. And then you have 2 by 3, then you have 2 by 3 square. And similarly, you will also have 2 by 3 cube and so on. Okay, so over here now you can clearly see that for this infinite, GP, you have R is equals to 1 by 3. Okay, so we quickly get our R over here. Now we have got this into a GP. So therefore, your infinite sum, okay, sum up to your infinity because this is an infinite, series we are saying. So your A is 2. So this will be A upon, because your R is again, R is less than 1. So you have 1 minus R. So you have 2 upon 1 minus 1 by 3. Okay, so this is going to give you 2 by 3. So this will give you 2 into 3 by 2. So this is 3. Okay, so your answer is 3. So we will stop here for today, and in the next class we will do a bit more examples, somewhat a little complicated ones also, and I will also try to solve few of the entrance exam sums also. So thank you so much for attending.